All of you, welcome back to course of computing. Our today's topic of video is introduction to Hebbian learning. So in the last video we discussed about learning vector quantization and we discussed about other techniques. Now in this video we are going to understand the process of Hebbian learning. So what is the concept of a Hebbian learning? So in order to learn the concept of Hebbian learning, we need to understand the concept of artificial neural network. So when I explain artificial neural network, at that time you come to know that ANN is a concept that is based on the concept of human brain. So artificial neural network is a concept that is derived from the concept of a human brain. Why is it so? Because in case of a human brain, what we have, neurons, millions and billions of neurons are connected with each other. So that ANN derive this concept from the concept of a brain. So that's why here I have mentioned that ANN is completely inspired by the human brain. And now the thing is that second thing is learning. So what do you mean by learning? How can you define learning? Learning means to do and adopt the change in itself when there is a change in the environment. Now in order to explain the concept of learning, I will give a simple example that we see in our real life, that whether you are in order to understand that your brain is human is learning or not, I will give a simple example. When you are a child, okay, when you are a small child, at that time by mistakenly suppose you have touched a particular metal which is very hot. So suddenly what you see, you just take out your hands from that place. Why? How this thing is happening? Because you have learned that the thing which is hot, you don't have to touch that. Suppose any particular metal or any particular object which is hot, we don't have to touch that. Means we can touch it, means we have some up to certain limit we can bear the temperature, but after that it's harmful for our skin, so that we need to take out our hands. So from this our learning is that suppose a particular object is hot, then we don't have to touch. So this is what a learning takes place in the human. Okay, this is how human learn. That we are saying that human is going to learn by its own mistake. Human is going to learn by its own experience. Most of the time we have seen that we heard about that a particular person is learn based on the experience, because that person already gone through that, so it understand that. Means in this case understanding is that suppose the particular object is hot, then you don't have to touch it. Okay, so this is what a learning. So this what do you mean by learning? Learning means adopt the change in itself. In this case, in the example, suppose the particular object is very hot, you don't have to touch it, or if you touch it, you just take out your hand. That means you have adopt a change in itself when there is a change in the environment. Suppose you are you are standing on the road and suddenly there is a rain. So what will happening? You just go to particular place and you just take the shadow of that particular you just go out to any particular shop which is present beside the road. So this is what a learning. Suppose there is a rain, so don't have to get wet. Suppose you are getting wet, you may face a problem. you may suffer from the problem. You may suffer from cold also. So the learning is that when there is a rain, you need to be in a particular place where you can be safe. So this is what a learning. That means suppose there is a change in the environment, according to that you have to adopt a change in itself. Now this is the ability that is adopted in the human being, but we want that same ability to be adopted in the machine itself. So for that purpose there is a concept of artificial neural network. That means artificially we are try to mimic the human behavior into the machine. So ANN will mimic the learning capability of a human being. So this is how we are focusing on learning, how learning will take place in the brain. Similarly learning will take place in the artificial neural network, because artificial neural network can be used to perform various tasks. Let's say take a simple example of classification out two things, whether particular object object is a dog or it's a cat. Okay, so you need to classify between these two. So in that case you can use ANN to classify the picture whether it is a dog or cat. So in human brain learning will takes place. Okay, so similarly how learning will takes place in the machine or in case of artificial neural network. So in that case, what is that? Modification in a weight. We have seen that in case of artificial neural network there is a input layer, there is a hidden layer, and there will be a output layer, but all the nodes which is present in the hidden layer, input layer, output layer are connected with each other by means of a weight. So what is that weight represent? Weight will represent the priority of that input or priority of that node in the another node. It will represent the priority. The weight is very important. So modification in the weight between the two neuron represents the learning in the artificial neural network. And this learning in ANN, how learning will take place in artificial neural network, is inspired on the theory of Hebbian learning. That's why I tell you this complete story, because I need to tell you what is the importance of Hebbian learning, how Hebbian learning comes into existence. So for that purpose we understand the process of learning in the human brain, then we understand that how learning will take place in the ANN. So in order to modification of weight is important for learning in case of artificial neural network, and how that learning will takes place, that is inspired by the Hebbian learning. Actually in the year of 1949 Mr. Donald Hebb proposed it is one of the Canadian psychologist, proposed one of the key idea in biological learning, and it is known as a Hebb's law. Okay, that Mr. Hebb was a Canadian psychologist who have given a particular law, and that law is called as a Hebbian law. And according to the law, it specifies how much weight between the connection between the two neuron has to be increase or decrease in a proportion to the product of their activations. Means the thing is that in order to give learning capability to artificial neural network, the weight has to be updated. So in that case, sometimes the value of weight has to be increased, sometimes the value of weight has to be decreased, and related to that Hebbian law is there. Now let's discuss in detail what is that Hebbian learning or Hebbian learning rule, or you can say Hebbian learning law. So Hebbian learning is that learning which specify how much weight has to be increase or decrease in proportion to product of their activation. So in this case these two things are important. If two neurons are activated synchronously, means at the same time, if two neurons are activated simultaneously, then the weight of the connection has to be increased. Means if activation of two neurons at the same time will result in the increase in the weight, and if two neurons on the either side are not activated simultaneously or asynchronously means not at the same time, then weight has to be decreased. These are the two important rules given by the Hebbian, when weight has to be increased and when weight has to be decreased. And it is very well explained with the single line: a cell that wire together fire together. This is what the main concept of a Hebbian learning. Now let's try to understand with the help of one diagrammatic representation. Now in this case I consider these two neurons. This is a neuron I and this is a neuron J, and we know that in the human brain n number of neurons are there which are connected with each other. Similarly in case of artificial neural network, we have seen that n number of nodes are present in the input layer, output layer and the hidden layer, and all these neurons are connected with each other by means of specific weight. So in this case we consider this is a I neuron and this is a J neuron, and this Wij will represent the weight between this I and J. And what is that Xi represent? Xi represent the output which is generated by neuron I, and this the output generated by neuron I is treated as input to neuron J. This is what an important thing. Output generated by one neuron is considered as an input for the another neuron. So in this case we have two neuron I and J. This is a weight between these two, and Xi is the output. So here what we are providing this as a input to this J, and we consider this as a presynaptic neuron firing signal. And similarly now this is a neuron J. Now here post synaptic neuron firing signal, and it is represented by f net of j. So in this case wij represent the weight between these two. It is considered as a presynaptic neuron firing signal, whereas it will represent the postsynaptic neuron firing signal, and it is represented by f of net j. Now let's discuss this about this table. So in presynaptic neuron firing signal, suppose we have plus, that means here plus, and here also we have plus. In presynaptic and postsynaptic we have plus. So in that case what you need to do, that means both the neurons are activated at the same time. Okay, in this case in the presynaptic neuron it is plus, and in postsynaptic neuron it is also plus. That means both the neurons I and j has activated at the same time. That means in this case weight has to be increased. That means change in the weight, it is a positive. Increase means what? Positive, and decrease means what? The negative. Then the second case can be there, if two neurons are not activated, means these two are, the things are there, they are negative. So in that case also you have to increase the weight, because they are not activated, means both are synchronous. It is not the case that every time there should be a plus. Means if two minus is there, both the neurons are not activated at the same time, then there also increase in the weight. But when there is a asynchronous action, means there is a synchronous action. See, the thing is very simple. When the action is synchronous, at that time you have to increase the weight. When the action is not synchronous, at that time you have to decrease the weight. So in this case in this case it's very clear that both the plus are there, obviously you are going to increase the weight. So in this case few student may have confusion, sir, in this case both are negative, still you are increasing the weight, because I talk about synchronous. Means if there is a synchronous, if both the neurons are activated synchronously, then there is a increase in the weight. So though it is a negative, but both the neurons I and j are activated at the same time, that's why there is an increase in the weight. But consider this last two cases. In this last two cases what you have seen, one is a plus, one is a minus. Means in this case they are not synchronous, they are asynchronous in nature. So in that case weight has to be decreased. Similarly another case is there, one case is plus minus and second thing is minus plus. And so in both the cases we found that neurons are not synchronous, they are not synchronously activated, but they are asynchronously activated. That's why in this case, in last two cases weight has to be decreased, and in first two cases weight has to be increased. That means what learning is happening, means in case of NN how learning will take place, it's totally depend upon how the weight is modified between the two neurons. Because what is the ultimate aim of artificial neural network? In case of artificial neural network, you have decided what is your expected output and what is your actual output. Suppose you found the difference between actual output and expected output is large, then in that case you have to modify the weight. Now the Hebbian learning has given a rule according to that when we should increase the weight and when it should decrease the weight. So this is what a major understanding about the Hebbian learning, when weight has to be increased between the two neurons and when weight has to be decreased between the two neurons. So the thing is very simple. When two neurons synchronously activated, then weight has to be increased, and when the neurons are not synchronized, means when these neurons are activated asynchronously, then weight has to be decreased. So this is what a major takeout point that you need to understand about the Hebbian learning, Hebbian rule, Hebbian law, and so on. So I hope you understand what is the concept of Hebbian learning and what is its role in artificial neural network. Thank you.